Hello everyone. Today we're going to be covering within subjects ANOVA. We're going to use it when you have more than 2 scores for each person. This is different from between subjects ANOVA when you have 1 score per person per condition. So here everybody has a score for each condition. Between subjects ANOVA everybody only has 1 score and they only are in 1 condition. Sources of variance for within subjects ANOVA is going to be total equals between conditions plus within conditions, which also equals participants plus error. So within conditions equals participants plus error. So right here. We're going to talk about an ANOVA table because we have an ANOVA table for this as well. Very similar. We only remove the within variance. We still calculate it, but it's not in the ANOVA table. We have our favorite analysis, 2 keys post hoc, and we're going to do ADA, which is our effect size. We'll talk about SPSS very briefly. Real quick review of between subjects ANOVA. Total variance is how much each score differs from the overall mean. Within group variance measures how much each score differs from the mean for their group measured by mean squared within. Between group variance measures how much each group's mean differs from the grand mean. Things that contribute to variance in a between subjects variance ANOVA and a between subjects ANOVA is going to be the effect of the independent variable, everything else. This is why we have the bottom part over here, which is F equals between variance over within, which equals independent variable plus error over error. If our independent variable has no effect, it's going to be 1. And we test to see if it is greater by doing F obtained versus F critical. That's how we get and determine whether or not there is an actual difference. The ANOVA is always going to be a two-tailed hypothesis test, and hypotheses are going to be all means are equal, not all means are equal, because it doesn't necessarily have to be all or not equal. Within subjects ANOVA, notice we are using memory strategies again, how we recall words. Rote rehearsal is just saying the words again and again and again. We have imagery, which is using an image such as bear or ball. And then we can use a story, which is saying the bear hit the ball. We have our group means down here, and then our grand mean. Next, we're going to talk about the different types of variance. Between subjects, ANOVA has total variance equals between variance plus within. Within subjects has within conditions variance, which will equal participant variance plus error. The total variance is going to be between variance plus participant plus error, because participant plus error, as we just talked about, equals within. So it's really the same thing. It's just we're able to break down within group variance into 2 categories, participant and error. We're able to remove the participant, allowing us to get a more accurate representation of what's going on. Total variance, calculated exactly the same as an ANOVA for between subjects. Measures how much each score that each participant has differs from the overall mean. So each score for each that in each of their conditions differ from the overall mean. Between conditions, same as before. How much the group means differ from the grand mean, we'll do a sums of squared. We're going to go through it kind of quickly here. We don't need to know the math behind it. We're going to be focusing mostly on the ANOVA table. Within conditions was called within groups in a between subjects ANOVA. However, we're not calling it that exactly because we have conditions, not groups. groups means everybody was only part of one group. Everybody here is part of all the conditions, and it's just one major group. We're going to break this down into participant variance and error, also known as residual, which is whatever is remaining. Participant variance equals how much participants' average score differs from the grand mean. So we're going to take each person's score across however many conditions, take an average, and then see how much that differs from the grand mean. Variance for between subjects ANOVA, total variance equals between plus within, as we talked about. Within subjects ANOVA, total variance equals between plus participant plus error, which also means that we could do total minus between plus minus participant, which will equal error. And we will use that for the ANOVA. So again, in our ANOVA table, we will use total variance minus between variance minus participant variance will equal our error. For our example, our null is going to be wrote equals imagery equals story. And then we're going to have our alternative being at least one of the averages differs from the other. All right, let's take a look at within subjects ANOVA. We have our averages 3.5, 5, 6.75, grand mean 5.083. Sums of square total, again, each individual score minus the grand mean squared. We then add this up for each and every one of them. In this case, we're going to end up with 115.82. Sums of squared between the group means. So for the top one, we have rote rehearsal. We're going to take that 3.5 minus 5.083, square it, and then again, just like in between subjects ANOVA, we are going to multiply it by n, our sample size for that group, which is 8. We do this for all three groups. We add them together. We end up with 42.34. So again, we're going to do 115.82 minus 42.34 minus our participant, which will give us our error. We're now calculating within subjects. Within is the same way. Within is the same way as we did it in a between subjects ANOVA. So it's going to be, for instance, let's take a look at imagery. 4, which is the top one, minus 5, which was the group mean. It's going to be 4 minus 5, which is negative 1. Negative 1 squared is 1. And we do this for each and every group with the corresponding score paired to the corresponding group mean. We add all of those up together, and we're going to end up with 73.48. Participant. So participant is much more important than within right now. And so for participant, we're going to take a look at this one right here, 2. So it's 2 plus 5 plus 8, which will give us 15. 15 divided by 3 gives us 5. We had a average of 5.083, which will give us 5 minus 5.083. We square it, times it by 3. We end up with 0.002. So again, that's going to be 5 minus our grand mean, which was 5.083, squared, and then times it by 3. And why we times it by 3 is because that's the number of groups that we have. So the reason why we multiply it by 3 is because that's the number of groups we have. Error, sums of squared error can be calculated in 2 ways. It's the total minus the between minus participant, or we can do it as sums of squared error equals within minus participant. All right, for degrees of freedom, participant, little n minus 1, which means we have 8 in each group, which means we're going to end up with 7. Between, same as before, number of categories minus 1, which means it's going to be 3 minus 1, which will be 2. Error is participant times between. So again, error is just participant times between, which will give us 14. And total is the total number of data points. It is the total number of data points that we have, not the total number of participants, because we only have 8, but we have 3 data points for each participant. So it's 3 times 8, which gives us 24, which 24 minus 1 will give us 23. Notice our mean squared is still the sums of squared divided by the degrees of freedom. So MS is still sums of squared divided by degrees of freedom. And then F is going to be the mean squared between over our error. Previously, our error was within in a between subjects ANOVA. Here, we are actually just calling it error. So as we talked about before, we've got 7 for participants, 2 for between. Notice 7 times 2 gives us 14, which is our error. Total is 23. And then notice we can add these all up for our sums of squares, and that'll give us our total, which is why we can just do total minus participant minus between to give us our error. Mean squared, 52.4 divided by 7, 7.49. 42.34 divided by 2 will give us 21.17 for our between. 21.08 divided by 14 will give us 1.51 for our MS error. For our F ratio, it's going to be between over error, which is 21.17 divided by 1.51, and that will give us 14.02. We then need to look up our F critical, same way that we did before, for between subjects ANOVA. Our F ratio is going to be larger than our F critical, so therefore we have to run an effect size. We are using eta squared just like before, however with a key difference. Before it was over total, and total was between plus within. But since we know that the individual influences it, and we can actually identify how much each individual influences the scores, we're able to take that out. So it's still sums of squared between as the numerator, but the denominator is removing that participant. So we're just doing sums of squared between plus sums of squared error. And in our case, that's going to be 0.67. Post hoc comparisons. We're going to do Tukey. Same as between subjects ANOVA. We have our HSD. Now notice it says Q. It's going to be Q times the square root of the mean squared error over N. It's not Q times K times degrees of freedom error. It's not. That's just telling us what we need in order to look up our Q. We are going to compare each of our groups to each other. So we have rote minus imagery, rote minus story, imagery minus story. Now it's a good idea to remember that we're always going to be looking at the absolute value. In order to help you not have to remember that, sometimes it's better, or it's always better, to do the larger minus the smaller, so this way you always end up with a positive value. Alright, our Q value is 3.7, our mean squared error 1.51, our sample size, or our total number of data points for each group is 8. So we do 3.7 times 0.434 becomes 1.61, and then we end up with rote and story being significantly different because that's 3.25, which is greater than 1.61, and then imagery and story being significantly different because 1.75 is greater than 1.61. For within subjects ANOVA, we are going to enter the data in the same way as a paired t-test, meaning that each condition gets its own column. Each condition gets its own column. We reject if the null, if the p is less than 0.05, we're going to use what's called the general linear model. It's a little confusing, but it does give us our effect size. It doesn't calculate post hocs, which is a little bit of a bummer. We're going to graph it the same as for a paired t-test, meaning we will use legacy dialog summary for variables using the simple bar and enter in each variable, in this case our columns and our conditions, into the bars represent. Lastly, the APA style is the same exact as the between subjects ANOVA. The major difference, and the really only difference, is that when you're saying an ANOVA was run, you're going to say a within subjects ANOVA instead of a between subjects ANOVA. Take care. See you all in class.